Welcome to Leetcode problem number 57, insert interval, where I'll be going over how to solve this problem in Java in O of n time complexity. And if for people who are not familiar with the problem, basically you're given an array of non-overlapping intervals, and you're also given a new interval. Your job is to find where the new interval goes into the original interval array, as well as merging that with any intervals in the original array that are overlapping with the new interval. So it sounds a bit complicated, but I think it's easier if I go over a test case and it'll make a lot more sense. So the first test case given to us on Leetcode is where you have intervals, we'll just call it I, which is a two-dimensional array that stores arrays of length 2. And each array that's stored represents an interval. So you have 1, 3, and then you have 6, 9. So this is the original interval given in the first test case. And then you also have new interval. I can just call it ni for short. And then you have 2, 5. And essentially you want to put this into this original array in the correct position, but also merge it with any overlapping intervals. And I'll explain what it means to merge it and how to know if an interval is overlapping. In my algorithm, the first thing that I do is I just insert it on merged, and I find the correct place to insert it before worrying about the overlap or the merge or anything like that. I just find the correct place to insert it. And I do that by comparing the start value of each interval. If this is less than the start value of this first interval, then it's going to take that spot. In this case, the new interval start value is greater than the start value of the first interval. So, first interval can stay there. Next, I want to compare new interval start value to the second interval in intervals. As you can see, the new interval start value is less than the start value of the second interval. So I know that this new interval should be placed here, and then the second interval should be shifted up and actually take the third spot because the start value is greater. So if we just insert it unmerged, we can actually develop a function, which I'll later show you, that inserts it unmerged. I can just call it IU for short, insert unmerged. So then what we'll get is 1, 3, 2, 5, and 6, 9. So at this point you have the list that's inserted but it's unmerged, and basically now all you have to do is loop through the array of unmerged intervals, and then compare them to each other to find if any intervals are overlapping. In this case, these two intervals are overlapping. I'll try to explain it why in simpler terms, but basically I like to think of it as class time in university. So let's say you have a class from 1 to 3 p.m. and then you have another class from 2 to 5 p.m. This does not work. You can't make it to both classes because this class ends at 3 p.m. and this class starts at 2 p.m., right? So if that's the case, that means these intervals are overlapping. The two classes are overlapping, and you probably can't take both those classes. In this case, we can just merge them together into one interval. So in order to merge them together, you take the minimum of the start times. So if you see, the start times are 1 and 2. So you take the minimum, which is 1. Then you just take the maximum of the end times, which is 3 and 5. So 3 and 5, the maximum is 5. So it's 1 to 5. It's actually as simple as that. That's the merged interval. minimum of the start times, maximum of the end times. I'll show you how to do that in code. And then all you do is you place this back into the original array, and it sort of replaces the two intervals that were merged, if that makes sense. So then the result is, and the result is 1, 5, and then 6, 9. And it's as simple as that. So I'll get into coding it in Java, and basically, yeah, that's the correct answer. And all we need to do is make a function to insert it on merged, make a function to check if two intervals overlap, and then if they do, we also need a function to merge the intervals, which is quite simple. And then we just we call those functions as we loop through the list, and then we add it to a new list and then return that new list as an array. So let's get into the code. So now we can head into the Java code right here, and before we begin in the main function that's going to be checked by Leetcode, we want to create some helper functions. And the first helper function that we talked about earlier was the function that inserts it on merged. So it's going to return the same thing, a two-dimensional int array, and we can just do private int array. We can call it insert on merged, for example, and then it's going to need the same parameters. It's going to need the intervals array and the new interval, because it's just inserting the new interval into intervals at the correct location. So once we have declared this function, we can begin by first thing you want to do is you want to create a new array list, because it's easier to deal with than a two-dimensional array. It's easier to add intervals at certain positions within an array list compared to a two-dimensional array. And then we can treat that as our solution, and then in the end, instead of returning an array list, we just quickly convert it to a two-dimensional array and return that. So we can do list. It's going to be a list of integers. We can call it list equal new array list, and then in these parentheses we can do interval arrays dot as list intervals, and all this essentially does is creates an array list where each entry in the list is an integer array, and this just takes all the integer arrays and puts into from intervals and puts it into the list. Right, so now we have the list of the original intervals. Basically, all we have to do is loop through the original intervals, and we want to check if at any point the first value of the new interval is less than the first value of the current interval we're being looped to. And if that is the case, we just want to put the new interval in that position, and then the list will automatically shift to the right, and the new interval will be in the correct place. So we can just simply do that with a for loop. For int I equals 0, I is less than intervals.length, I plus plus, oops, my mic in the way. So now we do the conditional statement. As I said, if new interval at 0, which is the first value, is less than interval, can't type today, intervals at I. So that's just saying the current interval we're looking at, and then we do 0, the first value of the current interval we're looking at. If this is true, we know we found the position where the new interval has to go. So we do list dot add I new interval. So all we're doing is we're adding the new interval into the list at position I, because we found it. The fact that it's in this if statement means that I is the correct position. And we just add the new interval to the list right here. And then we're basically, if we reach that point, we're done. We know we don't need to loop more. The new interval's already added, and we break, right? But what if there's a case where this is never found? New interval is never less than any of the intervals. It loops through the whole thing, and new interval is never less. Basically, you just want to tack it on at the end. And then one simple way to do that is you want to first create a boolean is added, for example. You want to say false. And then right here, after you add it, you just want to do is added equals true, because you added it. Simple enough, right? Then right here, outside of the loop, you want to do one final conditional check where you say if it's not added. So you use a not, and then you do is added. Essentially, you're saying, is it not added? If it's not added, all you do is you add it to the end of the list. So you don't specify the index. When you don't specify the index, all it means is you just add it to the end of the list. That's how array lists work, which is pretty fantastic. And then after you do this final check and you add it to the end, or you add it here and you break, all you really have to do, that's pretty much it. You inserted it on merge. You just have to return it to the user. So return list dot to array, and then you specify the array size. So remember, we're returning a multi-dimensional array. So this first value is basically the amount of intervals, and all it is list.size, because list was originally intervals and then we added one, so list.size will be the correct amount of intervals. And then we also want to do 2, because there's only 2 values. It's always 0 for the first value and then 1 for the second value. So this returns it as a 2D array, and you're pretty much done with that function, right? And then before we start here, we do need some more helper functions that we haven't that we will need once we begin the main function that's being checked, and we'll get into that. So the next helper function that I'm going to do is the one that checks if an interval overlaps with another interval. So we can make it private boolean does overlap. And the parameters of this function is just going to be 2 arrays, and the names don't really matter, so you can just call them A and B. And essentially, we're going to loop through the unmerged intervals, and you're going to compare the current interval to the next interval within the list of unmerged intervals, and you're going to compare them and see if they overlap. So how you can do this is you want to take the minimum of the end values of an interval and subtract that from the maximum of the start values of an interval. If that's greater than or equal to 0, that means it does overlap. So before I code that, I can just show you exactly how that works. So let's say you have the interval 1 to 3. You also have the interval 2 to 5. So the minimum of the end values, so the end values are 3 and 5. So minimum of those values is 3, and the maximum of the start values is 2. So 3 minus 2 is equal to 1, right? So that is greater than or equal to 0, obviously. It's 1. So that means it does overlap. That means there's 1 hour. If you think of these as times, 1 to 3 p.m. and 2 to 5 p.m., there's 1 hour worth of time where it does overlap. But if it's the case where you have 4, 1 to 3, and 4 to 5, again, you want to take the minimum of the end values, which is 3, and then you want to take the maximum of the start values, which is 4. So 3 minus 4, that's -1. So, and you want to check if that's greater than or equal to 0. is not greater than or equal to 0, so it's false. So these intervals do not overlap. Obviously 1 to 3 and 4 to 5 do not overlap. So that's how you know it's working. So this is just simply one line of code, return math.max. You find the max of some math.min, as I said, the min of the n values. So math.min, a at 1 and b at 1 minus, so you take the minimum of the n values and you subtract it from the maximum of the start values, as was shown in the example. So you do max of the start values, a of 0 and b at 0, and then you want to check if it's greater than or equal to 0, and then the output of this will tell you if the intervals do overlap. If it's true, they do overlap. If it's false, they don't overlap. So now the final helper function is just to merge the intervals. So it's going to return, it's private int. It's going to return an interval, which is an integer array, and we can call it merge intervals. And it's going to be the same thing. It's going to take in 2 intervals. So let's say we check and we find that they do overlap. To merge them, it's actually very simple. All you do is you want to create a new integer array, merged interval, equal new int array with of size 2, because it's always intervals. In our case, the interval always only has 2 values. So then you do merged interval at 0. So the first value of the merged interval is equal to math.min, the first value of a and the first value of b. So it's the first value of the merged interval is equal to the minimum of the first values of the interval, of the 2 intervals. So it's quite simple. And then to get the last value of the merged interval, it's merged interval at 1 is equal to the maximum value of the 2 intervals, of the last values of the 2 intervals. And I know my explanation may not sound too good, but it's quite simple. You just take the minimum, you take the maximum, and then you get the merged interval. So then you just return that to the user. And now we're finally ready to begin our main function that's checked by Leetcode. And you could do it in a different way. You could begin this and then create the helper values as you need them. Helper functions as you need them. But for me, I just did it in a way where you get these out of the way first, and now you can begin the main function. So this is kind of a bit more complex, but nonetheless, it'll make sense. So the first thing you want to do is you want to create a list, because as we said earlier, it's easier to work with lists in Java, at least. And we can call it output, and it's going to be a new array list, and it's just going to be empty list, and we're going to add to it as we go. As we merge the intervals, we add the merged interval. We're going to add to it as we go. But before we do that, actually, we do need to call our helper function, because remember, as I said, we first want to just insert it unmerged. So we simply make intervals equal to insert unmerged, and then we call it with intervals and new interval, and it's that easy once you have the helper function. So now intervals is good to go. It's inserted unmerged. You want to create the list. that will be used as our output. We'll keep adding to it. And now again, we want to loop through intervals. So I'm just going to copy this for loop because it's going to be the same exact one. So for int I equals 0, I is less than intervals length I plus plus. Make sure I close the curly brace. And now we want to work with the current interval. So int current cur interval is equal to intervals at I comma 0. So that's the first value within the interval. And then the second value will be intervals at I comma 1. And essentially all this does is it makes the current interval equal to the interval at index I. That's all it does essentially. Current interval is equal to the interval at index I. You just take the same first value and the same end value. So now you want to continuously merge while I is in bounds, as well as the intervals that are being merged do overlap. You don't have to merge them if they don't overlap. So you could create the while loop while I is less than intervals dot length, and you want to check if the intervals overlap, so you can take your function name does overlap, and then in the parameters you want to use your cur interval, and you want to use the current interval that's being indexed, being looped. So it'll be interval at I. Let me see, where did my bracket go? Just gonna move this back here just so it's more clear. So now you're in the while loop, and essentially right now cur interval and interval at I is the same. And they do overlap, obviously, because if you have 1 and 3, and then as the interval at I, and current interval is also equal to 1 and 3, because that's the interval at I, then obviously they're going to overlap because they're the same thing. So they do overlap. All you want to do is update cur interval. Cur interval is equal to merged. It's equal to, we want to merge them now. Merge intervals. And it's going to be the same thing. You want to merge the two intervals that overlap. So you can take those parameters and put them in there. Boom. So now it's as simple as that. Cur interval is now merged. Then you want to I plus plus. Right? And then you want to keep hitting this for loop, as I said, while I is in bounds and while the intervals do overlap. It's going to keep merging it. So current interval is going to be, it's going to stay this. For example, we saw 1, 3 compared to 1, 3. And when it gets merged, surprise, surprise, it stays 1, 3, right? And then actually, when I goes up, it's going to check, does cur interval, which is 1, 3, does it overlap with interval at I? This time, I is not 0, I is actually equal to 1. But cur intervals stay the same at 1, 3, and I at 1, intervals at 1, rather, is going to be equal to 2, 5. And that's based on the unmerged list. The list of unmerged intervals. So actually, 1, 3, and 2, 5 do overlap. So this while loop hits again. And then cur interval is going to become merged, is going to merge the intervals of cur interval and interval at I. So it's going to merge 1, 3, and 2, 5. And if you follow this logic of merge intervals, when you merge 1, 3, and 2, 5, it actually becomes 1, 5. So then, so cur interval is now equal to 1, 5. I becomes 2. 2 is still less than intervals.length because intervals.length is actually 3. So it's going to hit this loop again. It's going to say, does 1, 5 overlap with 6, 9, which is intervals at 2? It does not, right? So the while loop's going to stop. And then what we want to do is we have the fresh list, and we want to add cur interval, which was 1, 5. So all we do is simply answer dot add cur interval, right? And then boom, I is now 2. It's going to hit this bracket here. It's going to increment I to 3 when it finishes this iteration of the loop. And then once it increments I to 3, there's actually an issue. This loop isn't going to run because 3 is not less than 3. 3 is not less than intervals.length. So what we have to do is we have to actually remember to decrement I in order to make sure it runs the correct amount of times. It needs to run one more time because right now answer would just be 1, 5, and it wouldn't check the final interval if we don't decrement it right here. So I is equal to 2, decrements to 1, it hits this, I goes back up here, and now I is equal to 2 again, right? So code's a bit messy, but cur interval is equal to 2, 0, and then 2, 1. In this case, it's 6, 9. Cur interval is this 6, 9 because that's the interval at index 2 of the full list that's unmerged. So it's the third interval or the second index interval in the unmerged list. So once it hits that, once it sets cur interval as that, it checks, is I less than intervals.length? Yes. Does the intervals overlap? Cur interval and interval at I. So in order to check cur interval, it's equal to 6, 9. Intervals at I is still 2, right? So I is still 2. It actually does overlap because 6, 9 overlaps with 6, 9 because it's checking against itself. So it does overlap. Cur interval, merge intervals. If you merge, it just stays the same. It's still 6, 9. So you're merging 6, 9 with 6, 9. And then I plus plus, this for loop, this I becomes 3. So this breaks because 3 is not less than 3. Intervals.length. I goes back to 2. Then you add 6, 9. So right now, if we're assuming I is equal to 2 and we're at this point, right now the answer looks like this: 1, 5, 6, 9, which is actually the correct answer. So I is equal to 2. It hits this. It increments I. I is now equal to 3. It checks against this. Is 3 less than 3? It's not. So this for loop breaks. And we have the correct answer. So all we have to do now is return the list to the user, but obviously we want a 2D int array, so we can just call the function that makes it a int array. So return output, which is the list, dot to array, and then we call it new int, and then we're going to do for the amount of intervals, which is the first value here, it's going to be output dot size. Then it's always going to be 2 because each interval only has 2 values. And this should work. I probably have some syntax errors, but we can try to run it. Okay, let's see. Forgot a semicolon. Classic. Let's see, hopefully this works. Okay, what did I forget this time? While I is less than intervals.length, and does intervals overlap? Interval Maybe I spelt it wrong. I said interval instead of intervals. Okay. Good catch. Another, probably did it again on line 46. Intervals instead of intervals. Cannot find. Okay, I accidentally put answer.add on line 50. It should be output.add. Hopefully this works. And fantastic, it seems to be giving the correct answer. And now we can submit.